We'll now talk about logarithms. This is one of the things in algebra that tends to be the hardest only because you have no basis for it. And it's the first time you've seen it, but overall the concept isn't super difficult once you understand some of the basics. So the idea is to start with an exponent. We know what b to the x means. It means multiply b by itself x times. So, as an example, we know 3 to the 4th is 81. So a logarithm is another way to write this. In this case, I actually know the 3 and I know the 81, but I don't know the exponent. And that's what a logarithm is. We write log base b, so the base of my logarithm and my exponent are the same. We then have a y next, and we say it's equal to the exponent. And we can also go backwards. B to the x power is equal to y. So we do have this loop thing to help us remember them. In this case, we would have log base 3 of 81 is equal to 4. So let's look at actually evaluating some of these logarithms. Log base 5 of 1. Well, usually the easiest way to do this is set it equal to x and then move to exponents. In general, with logarithms, if we don't know where to go, the first step is to convert it to exponentials because we have a little more intuition with exponentials. So our base is 5 to the x power is equal to 1. So in this case, what is x? 5 to what power is equal to 1? Well, we know that anything to the 0 power is 1, so 0. X would be 0. Let's do some more. Log base 7 of 7. Once again, we're going to set it equal to something. We have 7 to the x power is equal to 7. So x is what? Well, in this case, we know that x is 1 because 7 to the first power is 7. Log base 4 of 64. If we say this is equal to x, we would have 4 to the x power is equal to 64. So 4 to what power is 64? Well, we know that it's not 2 because 4 squared is 16. Well, what about 3? 4 times 4 is 16, times 4 is 64, so 3. In this case, x is 3. Log base 8 of 2. This time we would have 8 to the x power is equal to 2. 8 to what power is 2? Well, this one's a little bit more complicated, but we can figure it out. Well, how can we relate 8 and 2? Well, we do know that the cube root of 8 is equal to 2, and we know that a cube root is the same thing as a 1/3 exponent. So in this case, x is just 1/3. What about log base 5 of 7? Well, this time I would have 5 to the x power is equal to 7. So what is x? And in this case, it's actually really complicated because we don't know. We know that 5 to the first power is 1, or 5 to the first power is 5, and we know that 5 squared is 25, so we can say it's somewhere between 1 and 2, probably closer to 1 since 7 is closer to 5 than 25, but overall, we can't really say. It is an irrational number. This decimal would go on repeating forever, so we don't really know. And this is the real reason we have these logarithms, because we might want to talk about what the power of 5 that gives us 7 is. So this is the basic idea. There are some logarithms that we use so much that they have names, like log base 10 of x. This is called the common log. Base 10 is super common because this is our base for counting. We use base 10 in all of our counting in mathematics, so it's our common log. And so we usually just write this as log x. Therefore, if you don't actually see a base on your logarithm, that just means it's base 10, and we just don't want to write it. The other named one would be log base e, and here e is referring to Euler's number, which is an irrational number that's very common in mathematics. So this one is called the natural log. And it's called that because if you study these a lot more and you look at applications, this base e logarithm actually pops up quite often in nature. So we call it our natural log. And in general, we abbreviate this by ln. ln for natural log, written in the Latin form, where the logarithm would come first, followed by the word natural.